Hi everyone, and welcome to this session on Windows Server 2012 or 2 storage spaces, where I want to look at how you can use software-defined storage to provision more economic and great performing storage within your small medium enterprise, large enterprise, private cloud or public cloud. If you have any questions about today's event, make sure you go onto Twitter and have a look at #UK MVP Cloud. My name is Aidan Finn. I'm a Hyper-V MVP and I've been working with storage spaces technology since Microsoft released it in Windows Server 2012. I've been working with some of the larger architectures as well. I work as the technical sales lead for a company in Dublin called Micro Warehouse Limited, where we distribute some of the technology made by Data on Storage that I will be talking about later today that enables storage spaces. I've been working in IT since '96. Virtualization, Windows Server, Desktop Management, System Center. I've also written a few books with some of my MVP colleagues, and the last of those was Windows Server 2012 Hyper-V Installation and Configuration Guide. I tweet a good bit about Windows Server and related technologies as @Joe_Elway on Twitter, and I blog about this stuff on aidanfinn.com, and I'm the contributing editor for virtualization in the Microsoft space on the Petri IT knowledge base. Okay, skipping that, I've got a lot of stuff to talk about, so I'm gonna just jump right into this this topic. It's a big topic. There's a lot of cool stuff, a lot of interesting stuff in here for us tech nerds, and there's a lot of new things in here if you've been not keeping up with what's happened with Windows Server, particularly in the storage space. And if you've been working with traditional block storage such as SAN or NAS, a lot of this is going to be very new, might seem very alien, but don't worry, this stuff is heavily tested and it works really, really well. Okay, where do you normally want to store your virtual machines? Well, on Windows Server 2012 and later, we have the ability to store virtual machines on internal disk, DAS, which are not supported for clustering. But if we want to have highly available virtual machines, we could store those virtual machines on storage that's connected using PCI RAID, SAS SAN, iSCSI SAN, Fiber Channel SAN, and FCOE SAN. They're all supported for clustering. Now, while I'm talking about block storage, and before I move on to some of the software-defined storage stuff, I just want to remind you that Microsoft hasn't abandoned block storage. Microsoft has continued to invest in that SAN that you've invested in. One of the mantras for Microsoft is, the most economic storage that you can buy is the storage that you already own. And you may have already invested in a large SAN. Well, good news, because Microsoft has given us lots of functionality in the last couple of releases. ODX, or offloaded data transfer, makes the migration and movement of virtual machines and their files and the creation of virtual hard disks very, very quick. In fact, System Center Virtual Machine Manager 2012 or 2 can leverage ODX to speed up the deployment of virtual machines from a library that's stored on your SAN to your hosts, which are also storing the virtual machines on the SAN. Virtual Fiber Channel was given to us in Windows Server 2012 or 2, or Windows Server 2012, excuse me. And VMM 2012 or 2 will allow you to zone and provision that storage to your virtual machines, giving you great performing clustered storage for virtual machines. And we also got trim and on-map functionality. Now, if you'd like to learn more about this stuff, I'd recommend a blog by my Belgian MVP colleague, Didier Van Hooy. You can find him as @WorkingHardInIT on Twitter. Now, let's get into some of this Microsoft New Wave storage stuff. SMB3 is the newest version of Microsoft's storage connectivity protocol. You will know it from using file shares. If you've been working in Windows administration for any amount of time, you've created file shares and you've permissioned them. That's the biggest leap you're going to need to learn about this stuff. You're going to use file shares to store virtual machines or even SQL databases. That might be scary at first. You might be worried about performance. I want to put all that aside. The performance of SMB3 is incredible. In fact, EMC, the owner of VMware, has declared in a white paper that they wrote that SMB3 is the future of storage. And if the owner of VMware is willing to say that about a Microsoft technology, I think we should take it pretty seriously. SMB is an old protocol, but it got revolutionized and reinvented in Windows Server 2012. It was originally called SMB 2.2, but Microsoft realized that this was something significant and it needed a whole new version number. So in the release candidate, in the RTM, it was referred to as SMB 3. And it's designed not only to compete with legacy protocols like iSCSI and Fibre Channel, but to beat them. And that's made possible because this technology works on 1 gig networking, 10 gig networking, Roki, which might run up to 40 gigabits per second, and even InfiniBand, which runs at 56 gigabits per second, and I'm pretty sure I heard about 100 gigabits per second being on the way. The things that make SMB3 so powerful, well, there's 2 features really. First is SMB multi-channel. If you have the right NICs, so NICs that support something called receive-side scaling, you can have multiple parallel streams of data over a single NIC. And that allows you to fill that bandwidth, and that's really important when you're talking about data connectivity between a client server or an application server and its storage. So if you have 10 gigabits per second networking, you want to be able to fill that with storage traffic. And we're able to do that thanks to RSS. Multi-channel can also aggregate NICs, so it will auto-discover NICs that reside between the application server and the storage, and aggregate their bandwidth automatically. And it does that with fault tolerance as well. And not only that, but it can aggregate RSS enabled NICs, so we get multiple streams over multiple NICs. And that allows us to push through 10, 20, 40, 80, 56 or 128 gigabits bandwidth. That's some really fast storage. But the downside of pushing data at that speed is that you start spiking the processor. So Microsoft also gave us SMB Direct, and this leverages something called RDMA, or Remote Direct Memory Access. Basically, it bypasses the Windows networking stack and offloads the processing to the NIC. And we have special NICs that are capable of doing this. They're referred to as iWarp, Roki, or InfiniBand. And if you have those NICs, you can push through huge amounts of data at very low latency and with very, very little impact on the processor. Now, thanks to these improvements, we now are allowed to store virtual machines over SMB3 connections on file shares. So if you have Windows Server 2012 or 2 Hyper-V hosts, you can store virtual machines on Windows Server 2012 or 2 file servers. Now, a file server by itself sounds like it's a single point of failure, especially if you're coming from the SAN world where you've got multiple paths to multiple SAN controllers which have multiple switches to connect to multiple disk trays. We can do that as well using Windows Server, and I'm going to get to that. But what you need to think about here is we've gone away from complicated protocols that we as Windows administrators don't necessarily understand, and we're moving towards TCP/IP, networking that we know, traditional Windows networking and traditional Windows file shares. So we're simplifying the provisioning of storage down to creating file shares and allocating permissions to our application servers, such as our Hyper-V hosts or SQL servers. Now, there are some cool side effects of SMB3 and investing in SMB3 networking, especially if you do go higher up into 10 gigabits or faster. The first thing I want to talk about is the fact that we're moving to simpler storage. By creating file shares rather than LUNs, we can add multiple permissions. So we can have multiple non-clustered hosts using a single file share, and we can live migrate virtual machines without moving their files between those non-clustered hosts, which is very cool. We can also live migrate virtual machines between different clusters. So in Windows Server 2012 or 2, one of the nice features we got to upgrade from Windows Server 2012 was cross-version live migration. If I have a Windows Server 2012 Hyper-V cluster, it might be accessing or storing its virtual machines on a file share. I can build a new 2012 or 2 cluster, give it permission to the same file share, and do a cross-version live migration of my virtual machines, where I'm literally just copying and synchronizing the memory of the virtual machines to transfer them to the new cluster. No movement of files required, so I get a much faster upgrade and migration to a new infrastructure. And that's pretty important for very large installations where they need to have mobility around a very large data center with large isolated networking footprints. SMB live migration, I talked about earlier in the Hyper-V session, is the ability to leverage 10 gigabits or faster networks to do very fast live migrations using the technologies such as SMB Direct and SMB Multichannel that I just talked about. If you've invested in an SMB3 network, you can turn on this functionality and make use of that existing investment, obviously with some QoS implemented within Windows to protect your storage bandwidth, but you can move your virtual machines around now at much better speeds, giving you much more flexibility and agility within the data center and your cloud, so your customers have a much better service. Now, let's get on to the core thing of this presentation, storage spaces. I want to talk about or make clear something at first. This is not Windows RAID of the past. If you've used Windows RAID in the past, in Windows 2000 or 2003, you probably had a pretty bad experience. I know I did. And it was great for exam questions, but nothing more really. Storage spaces is something very, very different. If you've worked with a SAN, you've worked with something very similar to storage spaces. You've aggregated and virtualized physical disks, and you've created new LUNs that span those physical disks. And when you create those new LUNs, you've configured your fault tolerance levels or your RAID levels. Storage spaces isn't RAID. It's moving beyond RAID, because RAID is limited realistically in its scalability and ability to restore with performance from failure. Storage spaces is software defined. It's provided and managed by Windows and overcomes a lot of the limitations in hardware RAID. In fact, to do storage spaces, you need some special hardware that's certified for storage spaces, and you must have no hardware RAID between your server and that particular JBOD or just a bunch of disks device. You aggregate the individual disks within the JBOD tray. That allows you to then virtualize or create virtual disks or LUNs from the storage pool that you've just created. And then you define your fault tolerance. I just want to visualize that a little bit because that was very wordy. So here I have a number of disks and I'll put them into a certified JBOD tray for storage spaces. In Server Manager, I will aggregate those disks into a storage pool. From the storage pool, I can create what you might call LUNs, but they're referred to as storage spaces or virtual disks. And when I create one of these, I define the fault tolerance. Now the one you're most likely to use in Hyper-V is a two-way mirror. Think of it as kind of being like RAID 10. It's not RAID 10, and this is a basic visualization. What it does under the hood is a bit more complex. But basically, every block that's stored is stored twice on two different disks. Three-way mirror takes that same concept, but instead of storing the blocks twice, it stores them 3 times, giving you extra fault tolerance. Simple is kind of like RAID 0. There is no fault tolerance. If I lose one of my physical disks, a simple virtual disk will fail. And parity, which is not supported for Hyper-V or SQL workloads, but is great for archive workloads, kind of think of it as being kind of like RAID 5. So it's parity with striping. And it gives you the best capacity out of your physical disks, but at a cost of performance. Now I mentioned that you need special hardware to do this. If you go onto the Windows Server hardware compatibility list, you will see that there is a special category under storage for storage spaces. You'll see a number of vendors on there. The brand that I work with at Micro Warehouse in Dublin is Data On Storage. And you can see 2 of their devices here, one which has 24 2.5 inch discs, and the other one which has 60 3.5 inch discs. We can have multiple trays, so that gives us increased capacity. And the big benefit of storage spaces is the cost. Because you're not locked into discs from a particular SAN vendor, you can buy discs from any vendor as long as the manufacturer of your JBOD supports them. So the vendor that I work with, they support multiple different manufacturers of discs. And that allows us to shop around and get the best pricing. People are always going to ask about what happens when disk fails. Well, you can have a hot spare if you want, or multiple hot spares. And this is an old technology we've known from the past in RAID. So, If a physical disk fails in our storage pool, a hot spare will automatically kick in. All the other disks will start writing their data to the hot spare, so we can get fault tolerance all over again. If you've experienced this with RAID, or if you experience RAID repair, you'll know that this is a slow process. And the reason it's slow is that single set of spindles on that single disk, that hot spare disk, is the bottleneck in the performance of this restore process. A single disk is being written to by lots of other disks. And that will slow things down. So Microsoft have given us a new way of doing things. And it's called a parallelized restore. And we can do this in Windows Server 2012 Word 2 storage spaces. We have multiple disks, but you'll note I have not designated a hot spare. Instead, I'm using that disk that would have been the hot spare as just free capacity. If I have a failure, all of the disks that store the duplicate data from that failed disk will write to all the other disks. And that means we get a much faster restore process. Instead of being bottlenecked by a single disk, we have lots of other disks that are participating in the restore process. So we have an accumulation of IOPS from those individual disks in the restore. We can also do fault tolerance across JBOD trays. If I'm a small installation, I'll probably only have one JBOD. But if I think I'm going to have some growth, I'll put in at least 3 JBODs and balance the disk numbers across each of those JBODs. So I can add a second and a third JBOD to my server or my servers. When I create virtual disks and storage spaces, the fault-tolerant blocks will be spread across the JBODs. So instead of my two-way mirror storing the fault-tolerant blocks inside a single JBOD, it will spread them across multiple JBODs. And this awareness or location awareness is made possible using something called SES, or SCSI Enclosure Awareness. If I lose one of these trays, my duplicate data is stored on the other 2 trays. And why is it 3 trays? Well, we need quorum. So if there's a split brain scenario, we know which trays to keep online. We also have tiered storage spaces, and this allows us to get the best out of the performance that SSD can provide and the best capacity out of slower disks. So for example, I could have a tray that has 8 SSDs, giving me incredible performance for that working set of data that's hot. And I can fill the rest of the tray with 4 terabyte 7200K disks. Those 7200K disks are cheap, but give me huge capacity. Storage spaces will maintain a heat map to track 1 megabyte blocks as they're being used during the day. Those blocks that are being used heavily will be transparently moved or promoted to the hotter SSD tier. And the colder blocks will be moved down to the slower or colder HDD tier, where we've got cheap, scalable, economic storage. And this gives us incredible performance and capacity. So it's the best of both worlds. An advantage of doing tiered storage spaces is something called write-back cache. You may not know it, but most services that need to have consistent data, such as Active Directory, databases, virtualization, and this includes Hyper-V and vSphere, will bypass the write cache by doing something called write-through. So if you have a nice big write cache, it's not being used by your virtualization. What Microsoft have given us with storage spaces, particularly tiered storage spaces, is the ability to do something called write-back cache. So when we create a virtual disk or a LUN in a storage spaces pool that has SSD and HDD disks, 1 gig of SSD capacity will be allocated to that virtual disk. And that 1 gig of SSD capacity will be used to absorb spikes in write activity. So if we do see a huge spike in demand for writes, we won't have a drop in performance of our service. That 1 gig of capacity will be used to speed up those writes. The writes go straight to disk where they are committed. And later they'll be promoted or demoted depending on their heat within the heat map. So now, what are our storage options for Windows Server 2012 and later? If we're doing clustering, we now have PCI RAID, SAS SAN, iSCSI SAN, Fiber Channel SAN, FCOE SAN as before, but now we can store our virtual machines on clustered storage spaces. That's possible. We can connect multiple Windows servers to a single JBOD tray. The number depends on the manufacturer. And we can also store highly available virtual machines on SMB3 shared folders. So we can store those virtual machines on a shared that's on Windows Server 2012 or 2012 or 2. A quick reminder about cluster shared volume. This is Microsoft's cluster file system. All the volumes that you enable as cluster shared volumes are active on all nodes in the cluster. There's a few changes in 2012, so redirected I/O is no longer required to do a VSS snapshot or a backup. And CSV cache allows us to dedicate up to 20% of RAM in our cluster nodes as a read cache for virtual hard disks. In 2012 or 2, that was boosted up to 80%. So we may use that on non-tiered storage spaces to have a huge read cache. So we could put lots of RAM into a server and use that to cache what we're reading from non-tiered storage spaces, boosting our performance incredibly. So how can we do storage spaces? There's a few ways we can actually leverage this technology. The first, which is going to be attractive to small, medium enterprises and branch offices and larger enterprises, is cluster in a box, or CIB. This is an enclosure that contains an entire Windows cluster. And that Windows cluster could be used in multiple ways. It could be used as a 2-node Hyper-V cluster, a 2-node SQL cluster, or something called a scale-out file server that I'm going to come back to later. The architecture or the hardware is Windows Server 2012 or 2 certified. And inside of it, you will have 2 servers, blade servers, that have independent power and networking. They have their own onboard storage for their operating system. And the 2 servers are connected using SAS connectivity to a JBOD that is built into the chassis. The 2 that you're looking at are made by Data. The top one is a 2U enclosure that has 2 dual processor servers with 12 shared 3.5-inch disks. And then the lower one has 2 blades of higher spec, again dual processor, 256 gig RAM, 10 gig networking, and 70 shared 3.5-inch disks. So that could be a pretty large 2-node cluster. We can do traditional clustering with storage spaces. So instead of connecting 2 servers to a SAN, we could connect 2 servers to a single JBOD tray, as you see in this simple example. So here we have a Data JBOD tray with 24 2.5-inch disks. That's certified for storage spaces. We have 2 servers that are each connected to that single JBOD tray. The connections are 6 gigabits per second dual SAS connections with MPIO. The 2 servers are then clustered, and then it's up to me how I use that cluster. Maybe I enable Hyper-V on the 2 nodes and I have myself a small 2-node Hyper-V cluster. Or maybe I install SQL Server and I have myself a SQL cluster. Microsoft also gave us a new architecture called a scale-out file server. In the marketing speak, this is referred to as a transparent failover, scalable and continuously available storage architecture. Now that's a lot of words, but in short, it's software-defined storage with fault tolerance. In fact, it's even beyond fault tolerance and high availability, because you shouldn't see any downtime if one of the nodes in this architecture fails. The concept is that we place between 2 and 8 physical Windows servers or cluster nodes in front of cluster-supported storage, including storage spaces. We provision LUNs on that cluster storage, such as storage spaces, and we convert those LUNs into cluster shared volumes, making them active. We enable a special role on the cluster called the file server for application data. It's also known as the scale-out file server, or SOFS, and that will use the IP connections of the cluster nodes to register its own computer name and its own DNS records within your environment. That role or that file server is active across all the nodes in that cluster. So up to between 2 and 8 nodes. And then we create file shares that are active on each of those nodes, that reside on that single clustered storage, so on your cluster shared volumes. We then set permissions on those file shares. We will add maybe Hyper-V nodes and Hyper-V administrators to the permissions. And then on our Hyper-V nodes, which are different physical servers, another tier of physical computing, we will store our virtual machines on those file shares. That sounds like a lot, and I'm going to show you some of this, and there'll be a quick demo as well to show you around this architecture. Here we have a large implementation, and this is a large implementation and is very similar to what Microsoft is doing internally within the Windows Server Build Labs. There are 4 JBODs here, each with 60 disks. Potentially with 4 terabyte drives, we've just under 1 petabyte of raw storage on this. If we implement two-way mirroring, we'd have half a petabyte of raw storage, or of fault-tolerant storage, excuse me. There are 4 clustered scale-out file server nodes, and each of those nodes, think of them as being like SAN controllers, is connected to each of the JBODs, and they will each have dual MPIO-enabled SAS connections. Those 4 servers will provision LUNs, so we might have 4 or 8 or 16 LUNs across the entire JBOD set. And those LUNs are active thanks to cluster shared volumes on those 4 SOFS nodes. We'll create file shares which are stored on the JBODs, and those file shares will be permissioned so our set of Hyper-V hosts can access those shares using highly performing and scalable and fault-tolerant SMB3 networking. If one of those SOFS nodes fails, we'll have a transparent failover. So IOPS, or speed of the virtual machines, will drop slightly for a few seconds, and then they'll be redirected to a more active, or an active and available node. This architecture really does work. In fact, I once did a live shutdown of one of these virtual machines, or one of these scale-out file server nodes in a presentation a few years ago, and I forgot to turn it back on. And I had a fully performing and capable scale-out file server architecture for about 3 months afterwards, and didn't realize, because I had no monitoring enabled, silly me, but I didn't realize that I actually had lost one of my nodes, and the system just kept on running. Okay, before I wrap up, I did promise I'd show you around some of this. So, here I have a scale-out file server node. Now, before I jump into some of that architecture, let's go into Server Manager, and we can see that I've enabled storage spaces. If we go into Storage Pools, I have created a storage pool using a number of disks. In my JBOD, I have 2 SSDs, which is below the minimum required. I should have 4. And I have a number of HDDs. From this, I can go create new virtual disk, select my storage pool, name it, and tell it I would like to tier this virtual disk. So make the most of SSD speed and the capacity of HDD disks. Pick my fault tolerance level. I'm going to select mirror. And now I will tell it how much SSD capacity I'd like and how much HDD capacity I would like. Next, and I would create that, and a new LUN would be created. And you can see that I've got a couple of them here, and you can also see that write back cache is enabled by default. This volume here, or this virtual disk, has tiering enabled, and this one doesn't. And you'll see how I handle that later when I jump into System Center. Within failover clustering, my storage pool is here. In fact, this is how I created the cluster storage pool. I went right, new storage pool, and I walked through a wizard to select my disks. And my volumes are here. and I've converted them by right-clicking and going Add to Cluster Shared Volumes. From there, I went to Roles, and I clicked on Configure Role, and I added a file server for application data, also known as a scale-out file server. This appears to be owned by a single node, but it is actually active on both of the nodes within my cluster. You can see I've got 2 nodes. I right-clicked on here and did Add File Share, and I created a number of file shares for my Hyper-V cluster, which is a different tier of physical computing. I created 1 share per CSV volume. I've got 2 CSV volumes, remember. If we have a look, C, cluster storage, there are my 2 CSV volumes. And my shares are stored within the CSV volumes, making them fault tolerant. Now let's jump onto a Hyper-V host, in fact my Hyper-V cluster, and look at how I'm storing the virtual machines. This is another big leap for people, and it's a big leap for me. Where do I store my virtual machines? I store them on a UNC path. I don't store them on a local volume. I don't store them on a cluster shared volume attached to the Hyper-V hosts. I store them on a UNC path, the file share path of the scale-out file server role. And you can see each of the file paths there. Now let's go into System Center and see what's going on there. Here I have Virtual Machine Manager, and it's managing my entire Hyper-V fabric and my private cloud. I added a provider, Add Storage Devices, and you'll note that the default option is window-based file server. We can also add traditional block storage using SMIS or SMP providers. I added my scale-out file server, and it's managed using WMI and VMM agents on the individual nodes. My cluster shared volumes were discovered, and I classified them. In fact, I classified the one with tiered storage as being gold, and the one without tiered storage as being silver. If I look at my Hyper-V cluster and go to Properties, File Share Storage, you'll see the file share that's stored on the tiered storage space is marked as gold, and the other one is marked as silver. So when people are deploying virtual machines within my private cloud, they'll know what sort of storage they'll be able to access and what sort of performance they should be able to expect. And that is a quick tour around storage spaces. There's a lot more that you should read about. You'll see a lot of this on my own blog and on the Petri IT knowledge base. You'll also see friends of mine such as Didier Van Hooy in Belgium and Karsten Rockval in Germany talking about this technology as well. If you have any questions, make sure you ask them on #UKMVPCloud. My name is Aidan Finn. You can find me on Twitter as @Joe_Elway or blog on aidanfinn.com, and I'm on the Petri IT knowledge base. Make sure you check out the CloudOS website and learn a bit more about the MVP community as well. Thank you for tuning in. Bye.